Hello, today we will be discussing Pangaea, what it is and how it formed, as well as how it broke apart to what it is today. Pangaea was a continent that existed around 300 million years ago to around 100 million years ago, from the Permian period to the Jurassic period. Pangaea consisted of all the land together in one big supercontinent. The name Pangaea comes from Pan, which means entire, and Gaea, which means earth, which put together means entire earth, or all lands. The idea of Pangaea originated from a German meteorologist named Alfred Wegener, who fought in World War I and was a heavy smoker. In his life, Wegener went on 4 expeditions to Greenland to study meteorology in the Arctic. Wegener came up with the continental drift theory that at one point all the continents were once connected to each other to form a big supercontinent, but then the continents drifted apart from one another to form the current world. So, what evidence did Wegener have that all the continents were connected to one another? Well, Wegener realized that the east coast of South America and the west coast of Africa, if put together, would fit together like two puzzle pieces. In addition, Wegener realized that there were organisms that were similar to each other that existed in different continents. One example of this was the Mesosaurus, a now extinct lizard which lived exclusively in fresh water. Wegener found this lizard's fossils in both South America and Africa. So, how could this lizard cross a salt containing ocean to a faraway continent hundreds of miles away? Wegener believed this was another piece of evidence showing that at one point, millions of years ago, South America and Africa were once connected to each other. Another piece of evidence Wegener presented to show proof of Pangaea were fossilized plants from the Arctic archipelago, islands of Canada that are in the Arctic Sea. However, even though these islands are in cold climates, the plant fossils show that the plants were from tropical climates. Wegener believed that at one point, these islands were in warmer temperatures, which allowed these plants to grow. Wegener also realized that the geology of the Appalachian Mountains were similar to that of the Caledonian Mountains in Scotland, even though they were far apart. He proposed at one point they were connected to one another and have since then separated. At the time, people believed he was crazy. This was because Wegener didn't have any concrete proof of how continental drift worked. Wegener came up with several different theories on how it happened, involving the Earth's rotation and the gravitational pull from the Moon and Sun, but none were conclusive enough to prove continental drift. Because of this, his theories were rejected until later on. Over time, more and more evidence was collected showing how Wegener's theory of continental drift might be correct, continuing after his death in 1930. Some of the evidence was similar fossils and species in opposite parts of the globe, as well as scrapes on the bottom of the ocean showing how glaciers might have moved over time. The key piece of evidence came after World War II when scientists used seismometers to map the sea floor. Seismometers can detect where earthquakes are and can detect vibrations. What scientists discovered from mapping was the most earthquakes, volcanoes, and other geological movements formed along clear paths called belts. These belts were the outline of the tectonic plates. Tectonic plates make up the outer crust, which is called the lithosphere, of the Earth. All the continents and oceans sit on top of these tectonic plates. One famous belt is the Ring of Fire around the land surrounding the Pacific Ocean. This area is known for having lost volcanoes and earthquakes. So, why are tectonic plates so significant? Well, it turns out they are the ones responsible for all the movement going on with the continents. Tectonic plates are also able to move because of convection currents associated with molten rock under the Earth's mantle, the heat causing the rocks to expand. The higher temperature rock is less dense and therefore rises, causing the colder rock to sink. This convection current can cause the tectonic plates to move away from one another in a process known as seafloor spreading, because this can cause valleys and ridges to form on the bottom of the ocean. The molten rock cracks open the crust, the top layer of the Earth, and cools, forming igneous rock. Because the tectonic plates are moving away from one another, the continents on the tectonic plates move with it. The tectonic plates moving away from each other is what caused Pangaea to break apart to what it is today. After mechanics of tectonic plates were found, they replaced the theory of continental drift and is currently accepted as the reason why continents move. Even though Pangaea is the most famous supercontinent, there have been several supercontinents that have preceded Pangaea. Pangaea is the most well known because it is the most recent supercontinent. Well before Pangaea, the supercontinent Rodinia formed about 1 billion years ago. Rodinia, the only substantial landmass at the time, was at the southern part of the Earth, around where Antarctica is today. Because there was only one landmass, there was only one ocean, the Panthalassic Ocean. Around 600 million years ago, the supercontinent started to split apart. After another 100 million years, parts of Rodinia split away and drifted north. The supercontinent that remained is called Gondwana. The pieces of land that drifted north split into three different landmasses, one called Laurentia, which is current-day North America, Baltica, which is current-day Northern Europe, and the third Siberia, which is still Siberia today. During this time period was also when multicellular organisms formed exoskeletons. This was a major step in evolution and led to many of the organisms we know today, like snails and ants. 300 million years ago, Laurentia and Baltica collided. This caused the present-day Appalachian Mountains to form from the land colliding into each other. In addition, the land masses started to move away from the south and drift northward. During this time period, there was a sudden change in temperature which caused Earth to go into an ice age that would last 60 million years. At this point, a second ocean has formed, the Paleotethys Ocean, in addition to the Panthalassic Ocean. 200 million years ago, the supercontinent is now called Pangaea, the most recent supercontinent. This was the time period when dinosaurs roamed the Earth. The supercontinent has now drifted northward towards the North Pole. There were still two oceans, but instead of the Paleotethys Ocean, there is now the Tethys Ocean. 100 million years ago, Pangaea started to break apart. North and South America started to break away from Africa and Europe, which allowed the Atlantic Ocean to flow between them. India broke away from Africa, and Antarctica broke away from the bottom of Pangaea and drifted south. 50 million years ago, India collided with China to form the Himalayan mountains, and Africa hit Europe to form the Alps. Australia started to break away from Antarctica and drift north. Caused by the Americas and Australia's movement 20,000 years ago, water currents and climates changed. Ice glaciers went through North America to form the Great Lakes. This was the last major process that the Earth went through to form the modern world. However, this isn't the way the world will always look. In 250 million years, the continents will once again come together in a horseshoe shape. The continent will then be called Pangaea Proxima. Africa and Antarctica will move northward, causing the Atlantic Ocean to shrink and eventually be surrounded by land, causing it to become a sea. The continent's movements caused a massive dispersal of species across the globe, leading to increased species diversity. How is this so? With the massive supercontinent splitting apart and resulting land masses drifting farther away from one another, it was possible for individuals within a species to move to different parts of the globe and live in very different environments. This caused them to adapt and change their physical features, forming new variations of the original species. Species diversity is desirable because it leads to the sustainability of an ecosystem. Thank you for watching my video. I hope you learned something about Pangaea. See you next time.